Hey guys, this is Carrie Rhinehart with 5-Minute Math. Today I am looking at literal equations. If you're following along in the book, this is from Algebra 2, Unit 1, Lesson 1. You can also find this content in Algebra 1. This whole first unit is a review from Algebra 1. So we're looking at literal equations, and literal equations is when you are given an equation with several different variables and you're trying to get a specific variable by itself. For example, if we have A equals B plus R and you're asked to solve for R, okay, we're trying to get R by itself. So I'm going to draw my vertical line through the equal sign. Remember, what you do to one side, you've got to do to the other. And if we're trying to get R by itself, we need to get rid of everything else that's on the side with R. In this case, that's just B. So I need to get rid of B, so I need to do the opposite operation. That's an understood plus B there. So the opposite would be to subtract B. But remember, what you do to one side, you've got to do to the other. So I'm going to subtract B from both sides. It cancels out over here, and we're left with just R, which is what we want, equals. Now, A minus B, those aren't like terms, so I can't combine those. So I would just write A minus B. And now R is by itself, so we're done. I just like to write this on the left side. So we can just rewrite it, R equals A minus B. And you're done here. All right, let's look at another example. Let's say we have y equals the square root of x plus 2. And let's say we're asked to solve for x. We want to get x by itself. Okay. So we need to get rid of everything that's on the side with x. So that means we need to get rid of this 2, and we need to get rid of this radical. So now the 2 is under the radical with the x, so we need to get rid of the radical before we can move that 2. The opposite of the radical, which in this case it's a square root, the opposite of square root is squaring. So we need to square both sides. Remember, what you do to one side, you've got to do to the other. And the whole point in doing this is that a square cancels out a square root. So that on the right side, now we're left with x plus 2, just without a radical. And on the left side, well, y squared is just y squared. We still need to get rid of that 2 because we want x by itself. So the opposite operation would be to subtract 2 from both sides. So that those cancel. And now we're just left with x by itself, which is what we want. And on the other side, we've got y squared minus 2. So our final answer here is x equals y squared minus 2. I'm going to do one more. Let me erase these. I'll just erase this one. Leave that last one up. Okay, let's say that we have f equals x plus y over 3. Okay. I'm going to draw my vertical line through the equal sign. And let's say that we want to solve for y here. We're going to try and get y by itself. This is what we're trying to get by itself. So we need to get rid of this x, and we need to get rid of this 3. Well, when you have a fraction, there's understood parentheses around the numerator. So x plus y is an understood parentheses. And when you're moving from one side to the other with an equation, you go in reverse order of operations. So we've got to get rid of the 3 before we can deal with grouping. Well, right now, this means a fraction right here means that you're dividing by 3. This fraction bar means dividing by 3. So the opposite would be to multiply by 3. So I've got to multiply both sides by 3. Now understand, you're multiplying by 3 in the numerator. It's really like multiplying by 3 over 1. And the whole point here is that these 3's cancel. You don't have to write that 1 there, but I do want you to understand 3 is being multiplied in the numerator. So that on the right side, now we just have that x plus y, and we can drop off the parentheses because the fraction's gone. On the left side, 3 times f can just be written as 3f. Okay, we still want to get y by itself, so I need to get rid of that x. So I'm going to subtract x from both sides so that it cancels here. We get y by itself, which is what we want. And on the other side, I end up with 3f minus x. I can't combine those. They're not like terms. So our final answer here is y equals 3f minus x.